My teeny tiny monkey brain has been blown by these results. This is by far the best recasting result I have ever been able to achieve. And you and I are going to take a look at exactly how to do it. Just like Warhammer 40k, if you do it wrong, recasting happens to be one of them wallet-raping, money-burning, crippling debt hobbies you will likely never financially recover from. So, in an attempt to squeeze as much useful information from each experiment, I've been trying to document a record of the most promising approaches, improvements, discoveries, and techniques that yield better results than the previous experiments. Every flippin' recast attempt offers something new I can learn from, and my most recent experiment is by no means an exception. This latest mold of the Tau Broadside has produced by far the best recasting results I have ever been able to pull off. And the two primary reasons for this apparent improvement in quality were, first one being reinforcing the mold walls with additional rigid scaffolding, and second is relieving any possible pockets of air through the addition of extra vents. Compared to my earlier recast made from a standard cut mold, the new mold produces far less film in between the parts, and nearly all of the model pieces come out practically bubble-free. This is of course compound to a number of other smaller discoveries and tricks I've learned throughout my experience, and I will comment on those when you and I try to recreate a recast of the Tau Empire Broadside unit. Now, how about we get to it? Presently, when recasting miniatures, I have come to prefer to recast the whole sprue rather than taking out all the pieces individually, because sprues are easier to store, and sprue designs, which these miniatures come in, already provide the bulk of air vents that our recast will also need to use to allow air bubbles to flow up to the top and not get trapped, causing cavities and defects in your recasts. The first step would be to cut out a number of panels out of project foam board. Look at that. Now my camera doesn't know what the fuck to do. Nighttime! Daytime! Nighttime! Daytime! Of course, this piece is not going to be enough, so we're going to have to get a much larger sheet. First, when measuring the largest panels, make sure that you give yourself extra room at the top, as that space will be occupied by additional silicone, which will keep the two mold halves bound like a book. Second, give yourself a bit of extra room on the sides to make sure that your sprue has a thick enough margin from the edges of the mold, so that the final mold forms a wide enough seal and your resin or liquid plastic doesn't end up leaking out through the cracks or gaps when you press the mold halves together. We would also need two thinner strips, which would of course match the height of our last two panels. When cutting the panels for the mold box, I tend to go a little bit extra in the sizes because the design of a mold box that we're going to be using actually allows us to very easily resize the dimensions as we see fit. So in that case, it's actually better to have more and not need it than need it and not have it. Of course, the final piece is going to be the base of the mold box, and for that, I'm going to recycle this remaining piece of the project foam board I used in my last experiment. A little note I left for myself. I've been meaning to do this and I've done this once, but I totally forgot the results. I'm gonna make a record of how much silicone I'm actually using and what are the dimensions of the box that I'm gonna get as a result, so that next time around I could precisely calculate how much silicone I need for a certain amount of volume for my box. You may notice that the panels I've cut make for a strangely oriented mold box, and you would be right. We're going to be orienting the sprue in an upright vertical position for this one. And the reason for that is because from my countless failed, butcherized, sodomized molds, I have discovered that this orientation actually produces the smallest surface area for any possible bubbles to get trapped under when we pour the silicone. It's one of those pieces of wisdom I have discovered the hard way, after a few of my recast molds ended up littered with thousands of small air bubbles getting trapped underneath of the sprue. The next step is to determine what will be the most optimal angle to orient our sprue within the mold box we're about to build. What we're looking for is a sprue orientation which allows us to take advantage of the vents and flow gates that were already defined on the sprue and simply build on top of them. We're going to have to pay close attention to places where air can potentially get trapped, and those spots will end up with giant gaping holes in the model, and we certainly don't want that. So let's take a look at this. We can either orient it like this, or we can do so like this. Now I'm pretty sure this orientation will actually yield a lot less work on additional vents. Some parts might actually get screwed up. We're gonna have to place additional vents in this case, so this piece, there's absolutely no way for air to actually escape. This vent is too far. This vent is too far, the air is just going to get trapped right here, and that piece is going to be messed up. Same thing for any triangular pieces, like this piece here, that piece there. There's no air current, there's no passage for the air to escape, so that's going to get screwed up. This little button right here is actually going to get messed up as well. Same goes for this one. This piece is basically going to be missing entirely, I can guarantee that. We got this corner. It might be okay. It might not be alright. We might want to place an extra vent there. This piece is basically going to be missing entirely, so they definitely have to have a nice, tiny, short vent coming up the top. This top half is basically going to be missing if we're not careful enough. These could maybe use an additional vent in the corners just in case. I mean, honestly, if you're buying liquid plastic, especially those trial packs, I'm sure you don't want to be wasting stuff. So better safe than sorry. Place a few more vents if you're not sure. We've got some vents right here that we're gonna place here, here, here. Like, we need to basically double up these vents. These vents right here work fine for injection molding, which is of course what this type of plastic is. But you and I don't have $10,000 burning a hole in our pockets to be able to afford that kind of stuff, so we gotta make do with what we've got. I'm fairly certain the shields will end up all right. These little drone controllers are kind of iffy. You might place an extra vent here going up to the top. Same thing here, here, and then of course one more right there. These parts, we might want to connect little vents just in the corners here, going up there, or even like a double small vent going from the top to the side, top to the side, top to the side. Might even be able to just connect them to each other. Maybe. We'll see how it works out. The next step is to establish additional air vents in these pockets to make sure that air bubbles have a path to evacuate the mold and not get trapped, causing defects. I use a simple, common hot glue gun. And to pull this off, I carefully dab the hot end of the glue gun onto the model region that requires an additional vent and very lightly extrude a small strand of glue towards the closest point on the sprue. The hot glue seems to work quite well, and it's fairly easy to detach from the original sprue afterwards, but eventually maybe I should play around with alternatives, like maybe one of those 3D printer pans that extrudes PLA filament. I swear, if we could actually collectively design a much smaller nozzle for these hot glue guns, we would all win. Well, it took me a few tries, but I think I landed a pretty decent one. I'm generally trying to get the bulk of the glue to be on the sprue rather than on the part. We can't have it being too thin, because otherwise it might actually detach and we won't be able to catch it when we split apart the mold. And it can't really be too thick, because then, well, it's basically a thick blob you gotta cut off when you're separating the piece from your recast. This part here is real tricky. It's got lots of detail on it, and I don't think it really even needs one. We shouldn't really get any weird places where resin should pool, or I should say, we shouldn't really get any weird places where bubbles can form. Maybe. Now, generally speaking, you want to make sure that the vents you place are pretty gosh darn thick. We're gonna have to see how these two turn out. A very swift and gentle pass with a standard lighter is going to burn off any loose strands left behind without affecting your newly added vents. And on an off chance, if it did destroy your vents, then maybe you should have made them thicker anyways. Once I'm done with placing additional vents, I can move on to securing the sprue on a piece of project board and start building the mold box around it. This is where you come up against one very crucial sprue orientation detail that you absolutely have to pay attention to. I have fucked this up so many times, I'm legitimately concerned with how I managed to dress myself in the morning. Notice now how all the air vents we've placed allow the air to traverse upwards to escape? Well, make absolutely sure that when you mount your sprue onto your project board, you orient it at a 180-degree angle instead. You see, the resulting mold we will be getting out of this will have a small pool through which liquid plastic shall be poured in. The pool is actually going to be produced by the same blob of glue which will be securing the sprue in place on the project board. This means that once the mold is made, it will be logically rotated by 180 degrees. And if you happen to be a smooth brain like me and mount the sprue with the vents pointing upwards, then once you flip the mold, those vents will be pointing down instead, rendering the whole damn thing full of air pockets again. So make sure you pay attention to orientation. When hot gluing the sprue to the base, we have to make sure that it stands in an optimal upright position. In order to achieve this, I use a right angle bar or a right angle ruler to make sure the sprue's at a perfect 90-degree angle or as close to it, and then hold it in place until the hot glue cools and solidifies. After securing the sprue, I do a quick pass with the mold release spray from my local sculpture supplier. I use Sculpture Supply Canada for my supplies. They don't do any sponsorships or anything, I just like doing business with them as they always keep the product stocked and shipping rates are fairly reasonable, and they carry most of their supplies in just about any sizes, from little trial size packets to full-on gallon kits. Now, in terms of mold release, something I discovered about these miniature sprues is that silicone that we're going to be using to make the molds doesn't seem to stick or bond to the plastic first time around you're making the mold from them. That's a key word, first time around. It is likely they may be covered in some sort of thin coat of oil or oily residue from being handled prior. This does, however, stop being the case around the second or third time I make a silicone mold from the same sprue in a row, as the silicone starts to bond to the miniatures and it becomes a problem to clean off. So from here on out, if I haven't suffered enough, and if I remember, I apply a coat of mold release spray, let it dry, and only then pour the silicone on top of the sprue. The next step comes from the very discovery that made this whole video happen in the first place. You see, the biggest problem I've had to combat until now is the uneven distribution of resin or liquid plastic within the mold. Most often, I would experience a problem of resin pooling around the middle of the mold. When the resin pooling occurs, I end up with this thick plastic film occupying the space between the sprue and the miniature pieces. Sometimes this film is fairly tolerable, it's a part of the gig, part of the process, and removing it is, well, it can vary from a little bit of work to, a few minutes with a craft knife. But sometimes you get unlucky, and this film can get so thick that it's not even worth the trouble trying to post-fix. So, in order to try and combat this, I've been using clamps of various kinds to press the two mold halves together and minimize the gaps between the silicone. However, while fixing the problem of resin pooling, the clamps also introduce the opposite effect in other parts of the mold, resin deficit. This is where certain parts of the mold, especially the ones containing extremely thin walls, have been squeezed by the clamps so much that they were left without any resin whatsoever. And no matter what arrangement of what clamps I used, I would often end up with either pooling or deficit one way or another. In the end, all this nonsense required a lot of fixing, patching, or kit bashing to make up for all the lost parts. Now, the whole point of recasting is to get as close to the original result as I possibly can, and if having a few defects and inaccuracies was acceptable, I would have just stuck to 3D printing. So now the question was, how does one equalize and distribute the clamp pressure across the whole mold evenly? Do I use planks of rigid wood and sandwich the sandwich between them? Well, I have, and to be fair, there actually has been a fairly reasonable improvement, but it didn't really fix the problem outright. An idea came to me when I was watching a video called Why Concrete Needs Reinforcements by a YouTube channel called Practical Engineering. The host explained that adding inner reinforcements to concrete distributed the forces more evenly across the block, thereby improving its tensile strength. That's when I thought, why not apply the same concept to mold making? In hindsight, reinforcement may seem like an obvious answer for many seasoned prop makers and recasters, but for me, and I'm sure for many other hobbyist recasters watching this video, it was a brand new discovery. So now we need to assemble reinforcements for our mold walls. I used 3 layers of ice cream sticks to create a rigid mesh. Having made 2 of them, one for each half of the mold, I proceeded to hot glue them to the project board, using the right angle ruler to ensure they were as close to a 90-degree upright orientation as I could. I also tried to place these reinforcements as close to the sprue without them touching each other, so that I would minimize the amount of silicone I would have to use to create this mold. Now, having gone through this process of using a whole bunch of ice cream sticks to glue together what is supposed to be a rigid wall, I'm actually starting to think that maybe it's a good idea to look for alternatives so that I don't have to build one. Why don't you post in the comments your ideas for what can replace these ice cream stick rigid walls? I mean, to be honest, even just a flat slab of wood could work as well. It's just gotta be rigid. Next, we assemble the walls of the mold box using the previously cut project board panels. I would recommend splurging on extra hot glue at this stage. Make sure you plug up every possible crevice, hole, nook and cranny, because hot glue is cheap and you don't want your mold box falling apart, leaking expensive silicone everywhere. That happened to me once, and let me tell you, it was not fun coming back to the shop in the morning expecting a fully cured, ready-to-cut mold, only to discover that your stingy application of hot glue gave out and your mold box has accurately reenacted the Chernobyl's elephant's foot all over your desk and floor. Here is the reason why we decided to cut such large chunks for the little side panels. You see, when we build our walls, we can actually freely adjust how big the wall needs to be. So realistically, having a little bit of extra allows us to fine-tune the size as best as we can. Finally, it is time for us to mix and pour the silicone into the mold we've just made. Okay. I will be using MoldMax 29NV for this, which offers a very generous cure time of about 4 to 6 hours. This particular tub recommends to mix A and B solution in a 10:1 ratio by weight. I like to use these big yogurt containers to mix up the silicone. These are actually quite large in volume. What do we got? 650 grams. I would highly recommend that you go to your nearest dollar store and pick up yourself a whole bunch of these ladles. This is going to be great for pouring the stuff. Just don't forget to make a record of how much I'm pouring so that I can do the math in the future. I've done the math once, and I wrote it on the napkin, which I then threw away. Smart. I should probably screw in some hooks over here to this little ceiling area so they could hang down these spatulas and these ladles, so they can just droop back in the bucket. That's actually that's an interesting idea. Okay, we're at 681.5, so I'm gonna write that down. So this is how much A solution I have poured. So since MoldMax 21NV takes 100 to 10, which is 10:1 ratio, we should be able to get exactly 68.1 grams. Alrighty. Shaken, not stirred. Boop, boop. Good thing I wrote it down. My scale just went to sleep. Okay, 68.6. I always go a little bit over. It's not bad, but it also risks you having a whole bunch of A solution and none of the B solution left. Aha! I got more. To be honest, take my advice, it's sometimes better to just do 2 small batches or 3 small batches than doing 1 large batch, because let me tell you, this is a bitch and a half to mix right now. And you have to be careful with this stuff too. You gotta mix it nice and thoroughly. You can't even tell sometimes if it's fully mixed, because if you try to scoop anything from the very bottom, it's not really gonna appear because it's still covered by the rest of the mixed silicone. So, tricky stuff. Gotta be careful, gotta be thorough. I think maybe a drill with like a mixing tip could come in handy right now. I should invest in that. That'd be nice. It also doesn't help the particular ice cream stick that I just picked as the special child. Alright, here goes nothing. There's a common known fact that if you are pouring your silicone, make sure that you pour it always from the one same position. From one corner, one place of your mold. Because then, allegedly, it allows the silicone to seep in naturally into all the crevices. Now, I haven't been able to prove or disprove this, but I'm sure there's decades of prop making wisdom behind those practices. So we're gonna assume that they are correct. All right, so this here got us about, I would say, somewhere around halfway through the mold. Take the stick, dip it in, take it out. All right, here we go. So where are we? So we are indeed somewhere in the ballpark of halfway up there, more or less. Now, we don't need to go all the way to the brim, but we do want to get pretty close. So by the looks of it, we might need at least as much, if not just a touch more. At this point, it's also a good idea to inspect our mold for any leaks. This is where we left the mark, so that's fine. We do, however, have a leak right there, but not to worry because we have the hot glue gun ready to swiftly jump into action. I think for the rest of it, we've done a pretty bang-up job, I would say. Maybe right there, just a touch. I don't really see anything over there, but I just don't like the way the amount of light comes through there, so I'm just gonna be nice and safe instead of sorry. Sometimes your hot glue may actually take too damn long to solidify, so what you can do is you can take a piece of paper towel, and while the hot glue is still hot, just kind of press it against, and this will use paper towel as almost like a piece of scaffolding. By the looks of it, yeah, we need as much, if not more. Now, we did 681 grams. 681 grams, so we gotta do maybe at least 700 more. It's perfectly fine to keep using the same tub, because this stuff actually takes quite a while to solidify, so we still got maybe 30-40 minutes before it really starts to get going. So we can just reuse the same container. And there we go. Just a little over 700. This should better work, eh? Oh, that's right. Hold on. I gotta write this stuff down. 709. 709.7. Before the batteries run out. 79.7. So we need 70.9 of the B solution. It probably doesn't seem like it, but I've actually been recording pretty much non-stop for the past 5 hours. Yeah, usually takes about an hour to make one of these. But, you know, among all the script edits and it just got pooped by Silicone. Yeah, among all the script edits and changes and additions, any advice and piece of information I discovered, yeah, it adds up. Alright, here we go. The forbidden yogurt is now done. I am starting to see a little bit of white, which means very bottom of this isn't fully mixed. Just gonna quickly mix that up just a touch. Alright, now it seems like after adding a second batch of silicone, we do see some imperfections in the seal. So we are going to quickly patch these up. Uh-oh. Oh no. Oh no, I just saw a dip. Oh, the elephant's foot is coming! It has broken. It has broken. It has broken. Oh, jeez. Oh, Jesus. Oh, no, please don't. Oh, God. Okay. Well, I did not use enough glue. You know the thing that I told you? To use enough glue? Don't get stingy on the glue? Hey, well, guess what the fuck I just did? I didn't use enough glue. And this thing is falling apart. God, I caught this thing in just in time as it started dipping. I don't know if that's a win, however, because... Yeah... well, to be honest, this is kind of the first time I've ever used this much silicone in one single serving. So, yeah. Okay. Let's see. Solutions. What solutions do we have? We have clamps. We can use clamps. Okay. And then we can patch up whatever holes have just been formed. Okay. But as soon as I let go, it's gonna start sliding. Okay, so let's try this. Yeah, okay. As soon as I let go, it starts sliding. Technically, I did use clamps last time, but I totally forgot about them this time around. Okay, let me see if I can do some Spider-Man. Okay. Now it's in this drawer. There we go. Okay. I know which clamp I'm looking at or for. It's the red one. Oh, okay. All right. Here we go. And okay. Cool. The clamp is in. Now, because all the pressure's at the bottom, I'm just gonna move this up. Because all the pressure's at the bottom, I might have to clamp it from the bottom. Oh yes, there we go. Now, okay. Alright, we might be able to salvage this. Boy, how I wish I had more of these right now. Shit. Okay. If there was ever a more appropriate representation of recasting, this is it right here. This is actually it right here. It's this. Okay, now I think, for the most part, I think we've gotten the level of silicone back to where it's supposed to be, or where it was before. Okay. Alright. So the sticks are kind of rising, but I think that's the least of our problems. Okay. Let's think about it this way. First problem is that we need more clamps. I believe we need more clamps. That's right. And we need to somehow get this set of sticks down into the mold. Cool. Okay, so I have a plan for both. Here's what we're gonna do. Okay, these are very cheap clamps. So I am going to try this out. I'm gonna push this down. I'm gonna basically just dip this clamp onto this wall, and that, I believe, should hold down that part, at least. Okay. Now, it seems like the other half hasn't actually risen up. So, we're gonna place a clamp there just in case. Okay, dollar store clamps aren't really a good deal right now. Okay, let's try from this end. Okay, in the garbage you go. Dollar store clamps. Man, hey, at this point, this is just like performing surgery. Okay, now, what do we do with the disaster at the bottom? So, for now, any silicone that leaks out, we can still put it back. Because it's liquid, right? So, we should be able to just scoop it up and put it back. The problem comes from the leaks. You know what? I'm actually going to put this clamp at the top like this, so that it is simply holding down this sideways pressure. We can also help by placing a few of these clamps. Just a little bit. We don't just squeeze too hard. Actually, I might even want to lift that off just a touch. Now, what are we going to do about all the leaked silicone? Scoopa! Okay, this might seem like a pretty basic bitch strategy, but you know what? It seems to work. So I don't care. Well, it leaked. It leaked pretty spectacularly, but in the beginning of this video, I did say that every recasting attempt has something for me to learn from. And the one thing that I'm sure all of us can learn from is that if we are doing such a tall mold, make sure you use clamps to reinforce its sides, because there is going to be, based on the height, a tremendous amount of pressure pulling in to the sides. And I think no amount of hot glue is going to hold that crazy beast together. So, now, based on how much it has leaked, and based on how much it is leaking right now, I am fairly certain that the whole thing isn't going to leak out. It might be close to actually not even revealing the top of the sprue. And here's what's interesting. Even if the silicone does leak out, I can cut up the silicone that that spilled out. I can cut it up, and I can use it as filler for the next silicone mold. So, technically, all's not lost. Even if this thing does spill out, and it looks like this is baby elephant foot for today, this I can still cut up and I can still use it as filler because silicone bonds to silicone. So next mold can just get a bunch of filler instead of me mixing up and using up just as much silicone as I did today. So, all's not lost. We should be able to recover a good chunk of this. Okay, so I was going to make the second mold for the second sprue because the broadside comes in 2 sprues, but, well, I think I'm gonna wait for this one and see how much silicone is actually gonna leak out, which we'll have to see. And, well, I hope that there's plenty for you to learn in this one. We're gonna wait until tomorrow and see the disaster area.